agriculture is an integral sector of our country. It contributes about 17% of the total GDP and provides employment to approximately 70% of the population. As our country relies heavily on agriculture for its sustenance, the disease detection in crops has become of paramount importance. Manual detection of plant disease is a very cumbersome job. Hence, computational methods are used to make the process of disease detection more fast, efficient, and essentially human error-free. In our project, we have created an inception convolutional neural network model which helps us to detect the disease, if any. So without further ado, let us get into the first step of our model making, which is selection of dataset.
Dataset is one of the most important and vital aspects of any research study. The dataset used for our project is obtained from Google. It is an online community of data scientists and machine learning practitioners. We finally chose plant village dataset and settled on it. This dataset consists of 20,639 images, which is further classified into 15 classes. Note that the datasets come with a predefined training and testing subsets. After the dataset was loaded, the necessary packages were imported and we proceeded into splitting the dataset into training and testing part. That is 80% of the images into training part and 20% for testing part. More precisely, 16,511 images into training part and 4,120 images into testing part in order to facilitate efficient and quick handling of data. Followed by the dataset is put up with pre-processing techniques such as cropping the images, flipping horizontally, adjusting the saturation, contrast, etc. Pre-processing technique is essential to reduce the noise and segmentation of the leaves, which further increases the accuracy of the model. In our project, we cropped the leaf images to a uniform size. In addition to this, we have used data augmentation, which is a technique to create artificially more training data from the existing data. As a performance of the deep learning, neural networks often improves the amount of data available.
So going to the data set, data pre-processing and data augmentation part. Now we are here in the model section. In the model, we mainly have two approaches. One, training a pre-trained model using transfer learning technique. And second, building a CNN model from scratch. We have used pre-trained models like BGG16, LXNet, ResNet, DenseNet and Inception model in our project. We are going to see an Inception model we built which gave us the best accuracy for our project.
Initially, we are importing all the libraries we need for this project: sklearn, Keras, Matplotlib, and computer vision. Importing the dataset from Kaggle, defining epochs, learning rate, batch size of 32, input size of the image 128 by 128, converting those images into arrays, pre-processing the images. Here is the model, Inception model we used. Weights are pre-trained from ImageNet. Input size is 128 by 128 into 3. Here is the CNN model which we built, which will be placed on top of this Inception model and will be trained on our dataset. We are using Adam as our optimizer, binary cross entropy as loss function. Here is the model's summary. Generating the data using image augmentation, zooming, scaling, flipping the data, generating training set which will be used to fit the model. We are fitting the model with training set, and after training for 5 epochs, this model, Inception model, gives us accuracy of 94% with validation accuracy of 93%.
Resistant plants are a major threat to food supply as they cause reduction in quantity as well as quality of the agricultural produce. Our solution demonstrates the technical feasibility of deep learning using CNN model which is trained through image classification. With less computational efforts, the optimal results were obtained, which also shows the efficiency in recognition and classification of the leaf diseases. This led to distinguish successfully between the healthy leaves and different diseases, which were detected at the initial stage. A plant disease recognition system can work as a universal detector, recognizing general abnormalities on the leaves, provides clear benefit in the monitoring of large fields, as this approach provides a chance to discover diseases at the early stage, reduces the requirement of experts, and prevents huge losses.